Hi students, today we have to discuss about the modern periodic table. In the previous class we discussed some other periodic classifications, but it is the modern periodic table. It was in 1913. Henry Moseley rearranged elements based on their atomic number. This atomic number is an important point in this periodic table. It was because of the properties of elements are periodic functions of their atomic number. In the early classification, we discussed that the arrangements were based on the atomic mass. But the modern periodic table has a different one because it arranged based on the atomic number. And Henry Moseley found that the properties of the elements is periodic in nature based on their atomic numbers. Okay, then the atomic number gives the number of protons in the nucleus of an atom. He also explained that the number of protons should be equal to number of electrons in an element, and it is equal to the atomic number. Okay, then he explained the positions of positions of elements in the modern periodic table. There are 18 vertical columns. 18 vertical columns. Okay. These columns are known as groups, and 7 horizontal rows known as periods. 7 rows and 18 periods. Then groups in the periodic table signify that an identical outer electronic shell configuration. For a group, the outermost electronic configuration should be equal. For first group element, all the elements included in the first group have an outermost electronic configuration of 1. For second group, it is 2. All groups have similar outermost electronic configuration. The number of shells increases as we go down the group. Number of shells increases as we go down the group. The number of shells in first period is 1, second period is 2, third period is 3, and seventh period is 7 shells. Okay. The elements in the same period have same number of shells but different number of valence electrons. The elements in the elements in the second period have the number of shells equal, but the valence electron should be different. It is increasing. Okay, these are the properties of a modern periodic table. Then, generally, the number of electrons in the nth shell is 2n square. The number of electrons in the nth shell can be found by this equation 2n square. But some cases the valence electrons may be limited. In some cases the valence electrons may be limited. Is an extra point, you should note it. Okay, for example, for K shell 2n square, 2 1 square means 2. K is the first shell, so put n is equal to 1, then 2 into 1 square is 2. Okay, 2 into 1 square is equal to 2. So in the first shell, the kth shell contains only 2 electrons. In the L shell, it is the second shell, so put n as 2. Then 2 into 2 square is equal to 8. So L shell containing 8 electrons. In the case of M shell, the number of electrons is equal to 2 into 3 square is equal to 18, but the outermost shell have only 8 electrons. We should note it. For the outermost shell, that shell only occupies 8 electrons, not 18. You have to note this property. If the M shell is the outermost shell, then it only contains 8 electrons. The maximum capacity is only 8 electrons. Okay. Then trends in modern periodic table. What are the trends of valency? How the valency is changing in a periodic table. The valency is the number of electrons in the outermost shell. What is valency? Is the number of electrons in the outermost shell. We can say in that way. Then atomic size. The term atomic size refers to the radius of an atom. How this atom is bigger. The radius indicates the size. That is the distance between the center and the nucleus. Distance between the center and the nucleus is the radius of an atom. For example, the radius of hydrogen atom is 37 picometer. Picometer means 10 raised to minus 12. 37 10 raised to minus 12 meter is very small. Is the radius of hydrogen atom. So, in a periodic table, atomic size increases from top to bottom. Top to bottom. Atomic size increases when we go from top to bottom. So, the cesium and francium is bigger than hydrogen or lithium. Okay, so the atomic size increases from top to bottom. An atom decreases from left to right. So the largest atom, the largest element in periodic table is francium. Okay, then how the atomic radius change in periodic table? We want to find the reasons of this change. The atomic radius decreases in moving from left to right. Left to right along a period. Is a period, and left to right sizes decreases. That is why I represent this part as an arrow mark. It is small, in this side it is large. So as we move from left to right, size decreases. Also the atomic size increases down the group. Down the group increases. So largest atom is the in this side. Largest atom occupies here. Okay, then what is the reason? This is because the nuclear charge increases from left to right. In a period, as we go from left to right, the nuclear charge, the number of electrons in the valence shell increases. Here only 1 electron, here 8 electrons, here 7 electrons. So the number of valence electrons increases. It attracts more the electrons to the center. That is why they reduce their size. Okay, so this is because the nuclear charge increases from left to right in a periodic table. It attracts more to the center. That is the reason of the decreasing size at this side. Okay, then so the size of the atom is reduced. Then also as we go down the group, the number of shells increases. As we go down the group, number of shells increases. It increases the size. So the largest element occupies here and the smallest element occupies here. Then metallic and non-metallic property. Generally, metals are seen in the left side of the periodic table and non-metals seen in the right side of the periodic table. Generally, metals are seen on the left side of the periodic table while the non-metals are found in the right side of the periodic table. For example, metals, sodium, magnesium, they are seen in the left side. But non-metals, sulfur, chlorine, etc., they are seen in the right side. But some metalloids or semi-metals are seen in a zigzag line separating metals and non-metals in the right side of the periodic table. For example, boron, silicon, germanium, arsenic, antimony, tellurium, and polonium are the examples for semi-metals or metalloids. Okay, you can see the metalloids on the left side of the right side of the periodic table. Then what is electropositivity and how it changes in the periodic table? How the electropositivity is changes in a periodic table. So first of all, we have to discuss what is electropositivity. It is the tendency to lose electrons. Okay, electropositivity is the tendency to lose electrons while forming bonds. Generally, electropositivity decreases on periods from left to right and increases down the group. Electropositivity is the tendency to lose electrons. This is an atom, this is the nucleus. There is an atom in the outermost shell. For example, hydrogen. There is only one electron in the outermost shell. Then electropositivity is the tendency to lose these electrons. That capacity is called electropositivity. Then electropositivity generally decreases on periods from left to right. From left to right, it decreases. The electrons in the right side have a less tendency to lose electron, and the right side there is much more tendency to lose electrons. What is the reason? At this side, the charges are bounded very highly, the size is less, so these electrons are bounded with the nucleus with very force, so there is low tendency to lose electrons at the right side. Okay, that is the reason you have to think about it. At this side, the electrons are bounded very strongly, so we need to provide extra energy, so it is difficult to lose electron, so electropositivity is less at the right side. Then left side, it is larger. In a group, it increases as down the group. It increases as down the group. Electropositivity is very high for the largest element, and it is the element in the bottom side. It is the element in the bottom side. So electropositivity is coming from this side, and it is ended at this portion. The electropositivity is larger for cesium at this portion, and smaller for this side. Then what is electronegativity? Is another question just opposite to that of electropositivity. Electronegativity, how it changes in periodic table. It is the tendency to gain electrons. The capacity of electronegativity increases on periods from left to right. From left to right, it increases as down the group it decreases. It is just opposite to the electropositivity. You only need to study electropositivity and understand electronegativity is just opposite to that of electropositivity. Then another question, why oxides of metals are basic and that of non-metals are acidic in nature? Metals generally have electropositive in nature. Metals generally electropositive because they exist at the left side. Left side electropositivity is high. Electropositivity is high compared to the right side. So metals are generally electropositive in nature, so they have a tendency to lose electrons, and for non-metals there is a property to gain electrons, that is electronegativity. That is why the oxides of metals are basic and non-metal oxides are acidic in nature.